We're going to be looking at number systems, and we're going to start by looking at the number system with which you should be most familiar. That's the denary, decimal, or base 10 system. So we've got some of the number columns for this system here. Obviously, there are others. We would have 10,000s going this way, and then after that, 100,000s and so on. And in the other direction, we could have 1/10,000ths and then 100,000ths and 1 millionths and so on going in the other direction. So we might have a number here like 3,129.704. So 3,129.704. The 3 in the thousandths column represents 3,000. The 9 in the ones or units column just represents the number 9. Then after the decimal point, this represents that we have no hundredths, and this represents 4 thousandths, or if you like, 0.004. You should be aware that the largest unit you can have in any number column is a 9. Any of the digits from 0 through to 9 can appear in any particular column. So you can see here we've got a 2 here. That's in the tens column. That 2 obviously representing 20. Any of the digits from 0 to 9 could appear in that column, but you can't put 10 in there. To put 10 in there, you would have to spill 1 up into the hundreds and have a 0 in the tens. Each column represents numbers that are 10 times bigger than the column before. So for example, if this was a 1, this would represent 10, but this one here represents 100. So it's 10 times as many. A 1 in this column would have 1/100th of the value of this one, because a 1 here represents literally 1, and a 1 here represents 1/10. So you'd need to divide by 100. It's 100 times smaller. Another way of representing these number columns is with powers. So 1000 is 10 cubed, 100 is 10 squared, 10 to the 1 is just 10, 10 to the power 0 is 1, 1/10 is 10 to the negative 1, 100th 10 to the negative 2, 1000th 10 to the negative 3. And obviously we've got columns going off this way and off in this direction. And from here, of course, it's easy to see that numbers that are in this column are 10 times the value of ones in this column. So a 2 here would represent 2000, whereas a 2 here would represent 200. A 2 here would just represent 20, and a 2 here would represent 2. It's important to note that whilst base 10 arithmetic is what we use commonly today, and what most of you are familiar with, there are other number bases that are commonly used by people today. Historically, also, base 10 wasn't always used. Base 10 seems sensible because, of course, we have 10 fingers. However, people like the ancient Babylonians used a base 60 arithmetic system. We're going to look at some of the common ones in use today, such as binary or base 2 and hexadecimal or base 16. These are bases of arithmetic that are generally used in computing.